Hi, kids. All right, take a look at our graph. We have flux over here in Webers and time on the x-axis in seconds. You can see horizontal, then up, then horizontal, then down. And we have two questions. During which time intervals is voltage induced? And if the coil has 10 loops, what is the voltage induced for each of those intervals for number one? All right, so we should be thinking about Faraday's law. Faraday's law is number of loops, change in flux over change in time. So in order to induce a voltage, you have to have a change in flux. So the first interval, there's no change in flux, therefore there's no voltage. The second interval, there is going to be a voltage. So from 1 to 2 seconds, you're going to get voltage. 2 to 4, no change, so no voltage. And then 4 to 6, you would also get voltage. So which intervals would you get voltage? That would be 1 to 2 seconds, and then 4 to 6 seconds. If the coil has 10 loops, what is the voltage induced for each interval? So from 1 to 2, you would say, okay, 1 to 2, I'm going to have negative 10. My change in flux is going to be 4 minus 2, so my change is positive 2. And the time that it takes is 1, so I would get negative 20 volts. Or if you want, you could just leave it as 20 volts, as you can see right there. From 2 to 4, or 4 to 6 seconds, you would go negative 10. Final is negative 2. Initial is 4. So if I go negative 2 minus 4, I get minus 6 divided by 2 seconds. And you get 3, so you would get 30 volts. So negative 20 volts for this interval, positive 30 volts for the other interval. Well, what's the positive negative mean? What that really means is that if you were to induce a current, and I could ask you to find the current by using the Vernas equation, you'd have to know the resistance. But in one way, the current would go one way, then the current would go the opposite way. So if this was clockwise, that would be counterclockwise. If that's counterclockwise, that would be clockwise. Awesome. Bye, kids.